a reason on a free response question, we need to talk about the derivative. This is your reason. This is your definition. Okay, so whenever they ask us to find a relative maximum or minimum, we cannot say that there's a maximum here because the graph of f switches from increasing to decreasing. That is like the definition of a maximum. They already asked you for it. It doesn't show you know how to find it, right? It just says that you know what the definition of it is. So whenever we're asked to talk about a relative maximum or minimum, we're going to have to talk about the derivative. So we'll talk about the derivative changing signs for that. The relative minimum basically just switches the two things here. Relative minimum is going to switch from decreasing back to increasing. Therefore, the derivative switches from negative to positive. So, a lot of this is going to be very similar to what we did yesterday. Our conclusions are just going to be different. So, for example, if we have f of x equals 2x to the third minus 15x squared plus 36x plus 10, and they're asking for all relative extrema, we are going to take the derivative. So, f prime of x here would be 6x squared minus 30x plus 36. Okay. Then we need critical points, so we want to know where that derivative is equal to 0. So we're going to set this equal to 0, and we're going to solve that. I would just divide everything off by 6 first because it's going to be easier to factor if you do that. So you got x squared minus 5x plus 6 equals 0. A lot of times I find that like you have gotten so smart and you have so much calculus knowledge that it has erased some of your Math 1 knowledge that knows how to solve this. When you have x squared, you need a factor for that. So we're factoring right here. We'll have an x and an x. What numbers will I use for that?
-3 and
-3 and -2. So if you want to do a +1, -6, it feels like that should work, but it'll give you a -6 instead of +6, so you can't use that. So you're going to get x equals 3 and x equals 2 as your critical points. Now, when I make a chart for this one, I would do a chart like this. I'd put my 2 here, my 3 here, and I would use the factored version, x minus 3, x minus 2, and then your f prime of x. You don't have to. You can do a chart where you just plug it into 6x squared minus 30x plus 36. I guess technically I do kind of need to put the 6 out here. It's not going to matter for this problem because 6 is positive. But like if you had factored out a -6, it would change the sign of everything. So maybe instead of, I guess this is a little bit dangerous what I did right there because it's not still equal to the original problem. You might want to factor out instead of dividing it off there. It doesn't make any difference at all for this problem because that 6 right there is positive, and a positive number is just going to put like a string of positives across the top of this, and it's not going to change your answer at all. But if it had been a -6 that I was dividing off, it would change everything. So if I think of plugging in numbers here like 0, I would get a negative. If I plugged in 2.5, I would still get a negative. If I plugged in 4, I would get a positive. And then for the next line, if I plugged in 0, I'd get a negative. If I plugged in like 2.5, I'd get positive and positive. And you'll see that, like, here, like, you got a -3. Well, this one right here changes signs at the +3. You got the -2. This one changes signs at the +2. So the zeros kind of go with it.
So would you get the same if you plugged in like 0, 2.5, and 4 to the f of x problem and 6x squared?
Yes, you would. You would. So if you have one that's not like easily factorable or you're not quite sure about how to do it, you can just plug it into what you got to the derivative. It'll work the same. So you don't necessarily have to do that chart. You'll get the same values if you do that.
So the whole chart thing is not 100% necessary. So long as you use the derivative.
Correct. Correct. So like another option for this is for you to do f prime of 0 and get 6 times 0 squared minus 30 times 0 plus 36, which will give you 36, which will be positive. So this right here ends up being a positive for the first one. And so you can do that for these. It is a little quicker if you make the chart so that you don't have to do all of those calculations. You can do, like, the calculations are a lot more simple because, you know, like, that one's not too bad, but when you got to do f prime of 2.5, because this will be calculator inactive, then you got to do 6 times 2.5 squared minus 30 times 2.5 plus 36. And these will be calculator inactive. So that is where you start running into, it's a lot easier to plug that into the factored version of this. But you can definitely do it this way if you want. You'll get a negative here in the middle. You'll get a positive there on the end. So this question is not asking us for increasing or decreasing. It's asking us for extrema. So what is going to happen right here at 2? What are you going to have? You will have a relative maximum. And what will you have over here at 3? Relative minimum. So these, a lot like the others, have to have conclusions with them. So you would say f. I'm going to change the question. All x values of relative extrema. Most of the time they ask for like where they occur. Sometimes they'll ask for the y coordinate. If they do, you'll plug that in, but most of the time it's x values. So f has a relative maximum at x equals 2 because f prime of x switches from positive to negative at this point. And then we're going to have a similar conclusion for our minimum. F has a relative minimum at x equals 3 because f prime of x switches from negative to positive at this point. This is, you have to have all of this. This is required. You've got to say whether it's a relative maximum or minimum. You've got to give the point, and you have to tell that the derivative switches from positive to negative at that point. You could, if you want, say something like, which means that f switches from decreasing to increasing at this point, you could add something like that. That would give further explanation of why you understand what's happening, but you do not have to. What you cannot have is what I've got written in green alone, right? So it is not enough to say it switches from decreasing to increasing, because that is, like, this is our definition of a minimum, right, of our relative minimum. So that alone is not enough. If you add it in, it's fine. I would tell you not to, because you might accidentally switch increasing and decreasing and get it wrong and lose the point, right? So I would say don't do that. It's unnecessary. What you do have to have is you've got to talk about the derivative. This is your reason. Okay, so what's in green is just a definition, or I would suggest not even saying it. But if you did, it'd be fine as long as you also talk about that derivative. Okay, questions? Okay, example 2 says find all relative maximum and minimum points for f of x equals sine x plus cosine x on the interval from 0 to 2 pi. So this is same type of problem. We just have some trig that we got to deal with here, which always makes it a little bit more difficult. So the derivative is not too bad here. The derivative of sine is just cosine x, and the derivative of cosine is negative sine x. And so you are going to set that equal to 0, which means that you're looking for where cosine x equals sine x. If you take this sine x right here and move it over to the right-hand side, and you don't have any strategies really for solving that, you just need to think about what the unit circle looks like, right? And on the unit circle, where do sine and cosine have the same values? Pi over 4, because right here at pi over 4, you got square root of 2 over 2 and square root of 2 over 2. So x equals pi over 4 is one of your critical points. Where else? It is also over here at x equals 5 pi over 4. Because right here you've got negative square root of 2 over 2 and negative square root of 2 over 2. Okay, so those are our critical values. So we would need to make ourselves a line here where it tells us only to look between 0 and 2 pi, or else we'd have infinite answers. This would just keep going on and over and over and over and over again. But we've got pi over 4 and 5 pi over 4. Here is an example where it's not all that helpful to make a chart, because you've got cosine x minus sine x is your derivative. Those two things aren't multiplied, so in this case you really do just want to pick a point to plug in. So like right here between 0 and pi over 4, you really only have one unit circle value that's an option, right? Pi over 6. And that would be root 3 over 2, 1/2. So we would have f prime of pi over 6 would give us, we're doing cosine of pi over 6 minus sine of pi over 6. And cosine of pi over 6 is square root of 3 over 2. And sine of pi over 6 is 1/2. Which one of those is bigger, square root of 3 over 2 or 1/2? Square root of 3 over 2. Square root of 3 is bigger than 1, because the square root of 1 is 1, right? So this is going to give you a positive number. You don't have to know what it is. Don't try to figure it out. You just need to know it's positive. Then you're going to pick a value somewhere between pi over 4 and 5 pi over 4. And if you think about unit circle, that's anywhere right here. I would pick one of the like 90-degree angle sort of ones. I would pick like pi over 2 or pi At pi over 2, we've got the 0.01. So if we do f prime of pi over 2, we will get cosine of pi over 2 minus sine of pi over 2. And cosine of pi over 2 is 0, sine of pi over 2 is 1, and we're going to get a negative for that because we get negative 1. And then for here, we're between 5 pi over 4 and 2 pi, and I would pick 3 pi over 2, which is 0, negative 1, because those are the easier values to work with. So f prime of 5, actually I'm doing pi, 3 pi over 2 would be cosine of 3 pi over 2 minus sine of 3 pi over 2. And that would be, cosine would be 0, and sine would be negative 1. That's going to give you a positive 1 when you do that. So you've got a positive here. Is everybody okay here? All right, so what type of extrema do we have at pi over 4? That is a relative maximum because you are switching from positive to negative. What about at pi over 4? Relative minimum. So I know it's a pain to write it. I don't like doing it either, but if we really do need to practice it, we need to say F has a relative minimum at x equals 5 pi over 4 because f prime of x switches from negative to positive at this point. And then we will have a similar statement for our maximum. So F has a relative maximum at x equals pi over 4 because f prime of x switches from positive to negative at this point. Does that make sense?
So like before, like these problems, we were just where it's increasing and decreasing, but now we're just like stating the proof.
Right. So really, the only real difference between what you guys were doing last night and what you guys are doing now is what your conclusion is at the end. Because the steps are going to be the same. You'll find your derivative, you'll find your critical points, you'll make your sign line to see whether your derivative is positive or negative. But when they're asking you about those extrema, you're finding the places where your derivative changes signs, whereas earlier they were asking about increasing or decreasing or both. So you would say that it's increasing because the derivative is positive, or it's decreasing because the derivative is positive. Whenever we're talking about a maximum or minimum, we have to talk about the change in the sign. So the bulk of the work is the same as what you guys were doing last night. Okay, questions? All right, let's see. We're definitely not going to have time to do all this.
Because I'm curious, example 3 was a double chain rule, wasn't it?
Yes, example 3 is a double chain rule. let's do these multiple choice questions. We might come back to that one. This one is calculator active. Okay? So I'm going to, if you don't have your computer out, I'll graph it up here for you. We've only got a few minutes left, so no need to drag that out. All right, so we're going to graph. It's not going to like it if we call it f prime of x. Desmos does not like that unless you've already got an f of x in. So I'm just going to call it y equals x to the third minus 3x plus 2. Okay, so there's the graph. A says there's no relative minimum and one relative maximum. B is one relative minimum, no relative maximum. C is one relative minimum and one relative maximum. And D is two relative minima and one relative maximum. What do you guys think? C? You guys agree? C? You are wrong. It's not C.
Oh, yeah.
This graph has one relative maximum, one relative minimum. But is this the graph they're asking us about? Okay, so we are now in calculus. So in pre-calculus, they would have given you that graph, and they would have, and the answer would be C, right? So in pre-calculus, they asked you about the graph you were looking at. In calculus, they never ask you about the graph that you're looking at. So if you are looking at a graph, do not answer it from that graph. Like 99 times out of 100, you'll be wrong for that. So this is the derivative of our graph, right? It is not the function that they're asking us about. So if we think about that derivative, the derivative equals 0 at -2 and at 1. What's the sign for the derivative whenever you're over here below -2? It is negative because the graph is below the x-axis, right? What about between -2 and 1? It is positive. What about over here beyond 1? Still positive, right? So we haven't seen this happen a lot. We've got two critical points. They're -2 and +1. But is +1 a maximum or minimum? It is not, because you do not change signs on your derivative. So we just have a relative minimum right there at -2. So where's B? One relative minimum, no relative maximum. That's your
You
answer.
just want to see how many times you cross the x-axis.
Right. And you care about whether you went from negative to positive or positive to negative. So like right here, when I'm looking at this, I'm saying like right here, oops, I went from, as I go across right there, I went from negative up to positive, so that's a minimum that's going to happen right there. Here, I do touch the x-axis, but it's positive and still positive, so it didn't change. So that's not going to be anything at all. If it came back down and crossed here, like this, then you would be going from positive down to negative, then you would have maximum at that point. So you're looking at where you have zeros of your derivative and where they're changing signs. Does that make sense? It's confusing, and it's really easy to get these wrong and say, like, C is your answer for that. But know that in calculus, like, they're not trying to trick you. They're trying to test that you understand this, right? But it can feel like they're trying to trick you.
We should know it's not that easy.
Yeah, you should know it's not going to be that easy. In pre-cal, it was that easy.
You just think that that's that easy when you just keep thinking.
Right, right. Yeah. They pretty much are not going to ask you about a feature of the graph that you are looking at. Yeah. We go back to the good old days of pre-calculus where we just had to tell increasing or decreasing. That would be a little easier. Okay, let's look at this last one. Uh-oh, wrong thing. Don't worry, it's not going to be that many. Actually, let's see here. Okay, All right, so the function f is defined by f of x equals e to the negative x times x squared plus 2x. At what value of x does f have a relative maximum? So what are we going to have to do to take that derivative? Product rule. So we will do f prime of x is going to be, we will have e to the negative x, and then we must multiply by the derivative of x squared plus 2x. So that will be 2x plus 2. And then we will have x squared plus 2x times the derivative of e to the negative x. The derivative of an e to something is e to that something, but for this one you have to use a chain rule, and you have to multiply by the derivative of the negative x. What's that going to be? Negative 1. So you'll have like a negative 1 there with that. At this point, I would try to simplify a little bit because it's going to be kind of difficult to do this otherwise. And if you look right here, you've got an e to the negative x in this term and an e to the negative x in the second term. So we can factor that out. So we will get e to the negative x times 2x plus 2. Be careful right here, that negative 1 did not get factored out, so it has to get like distributed to this here. So you'll get minus x squared minus 2x. I think we had one that looked a lot like this yesterday. The 2 and the negative 2 cancel out, and we've got 2 minus x squared. You might even want to do this 2 minus x squared over e to the x. It doesn't really matter, but then you don't have to worry about negative exponents if you do that. All right, so we have our derivative. What do we need to do now? We're going to find where this equals 0 or undefined, right? And that means to find those critical points. So that means we've got to do 2 minus x squared equals 0. We also have to consider e to the x equals 0. So for this first one, I'm just going to move that x squared over to the right side, so I'll get 2 equals x squared. Then what do I need to do? Square root. And so I get plus or minus the square root of 2 as critical points. What about over here? I will natural log both sides, and you cannot take the natural log of 0, so you end up getting nothing from this. E to a power is always positive, so there's no way that's ever going to equal 0 right there. Because like even if we plug in 0, even if we do e to the 0, what's e to the 0 equal? 1. And even if we plug in negative numbers, like negative 5, that really is just 1 over e to the 5th, which is a really small number, but it's not 0. So you will not get anything from that. If you have a piece that's just a e to the x, most of the time that's what happens. If it's a e to the x plus 7 or something like that, it might be different. Okay, so our critical points are plus or minus square root of 2. So I could pretty much narrow this down to A and B, right? Because it's going to be the critical points, which means, I'm sorry, B and D, not A and B. Because it's going to be one of these two, but I need to know which one is a maximum, so I've got to do a chart to figure out which one switches from positive to negative. So if I make myself a chart here, I've got negative square root of 2 and positive square root of 2. And, you really, you can do 2 minus x squared and e to the x, and then you'll have your f prime of x here. You can make yourself a chart, but we just said e to the x is always positive, right? E to any power is always positive, so you're really only thinking about plugging numbers into this part right here. So give me a number smaller than the negative square root of 2. Negative 3, that'll work. So if I plug in negative 3, I would have 2 minus negative 3 squared, which negative 3 squared would give me 9, and 2 minus 9 is negative 7, so it'd be negative. What's the easiest number to plug in between negative root 2 over negative root 2 and positive root 2? 0. If you plug in 0, you will definitely get a positive there. And then if I plug in a positive number like positive 3, the same thing's going to happen, right? I'm going to have, if that's a positive 3 right there, positive 3 squared is 9. 2 minus 9 is also going to be negative. So really, this top line is the same as your bottom line right here. Which one of these is going to give me a maximum? The negative square root of 2 or the positive square root of 2?
Positive.
Okay, it is going to be this positive right here, because at this point my derivative switches from positive to negative, and that's where we have a maximum. So D would be the answer for that problem. Okay, we are going to significantly reduce your homework. I think Canvas is lower here, because I want you to think about it a little bit, but I don't want you to have to spend your weekend doing this. Let me see which ones I put on Canvas. Okay, we're just going to do these first 3 right here. We're going to practice some more on Tuesday, so we really should do more than 3 problems, but we'll do some of that on Tuesday. So 21, 25, 27 are the ones I want you to look at.
Oh, thanks.
Yeah, just those 3.
The same page as last time, right?
I believe, yes. Yeah.
Thank you, Nancy.
So and those are all still on the same page, so you should have.
Yeah, we really.
Oh, same page as last time?
Yes.
Okay,
Yeah.